Identify characteristics of the quadratic function and its graph. From the graph, you can see that the vertex is 2, -4, and the axis of symmetry is x equals 2. The function is decreasing when x is less than 2, and the function is increasing when x is greater than 2. The domain is all real numbers. The range is all real numbers greater than or equal to -4. When x is less than 2, y increases as x decreases, and when x is greater than 2, y increases as x increases. Graph g of x equals 4x squared. Compare the graph to the graph of f of x equals x squared. Begin with the graph of f of x equals x squared. Then make a table of values. Substituting -2 for x in the function g gives g of x equals 16. Similarly, when x equals -1, g of x equals 4. When x equals 0, g of x equals 0. When x equals 1, g of x equals 4. And when x equals 2, g of x equals 16. Next, plot the ordered pairs -2, 16, -1, 4, 0, 0, 1, 4, and 2, 16. Then draw a smooth curve through the points. Both graphs open up and have the same vertex 0, 0 and the same axis of symmetry x equals 0. The graph of g is narrower than the graph of f because the graph of g is a vertical stretch by a factor of 4 of the graph of f. Graph h of x equals -2/9 x squared. Compare the graph to the graph of f of x equals x squared. Begin with the graph of f of x equals x squared. Next, make a table of values. Substituting -6 for x in the function h gives h of x equals -8. Similarly, when x equals -3, h of x equals -2. When x equals 0, h of x equals 0. When x equals 3, h of x equals -2. And when x equals 6, h of x equals -8. Next, plot the ordered pairs -6, -8, -3, -2, 0, 0, 3, -2, and 6, -8. Then draw a smooth curve through the points. The graphs have the same vertex 0, 0 and the same axis of symmetry x equals 0, but the graph of h opens down and is wider than the graph of f. So the graph of h is a vertical shrink by a factor of 2/9 and a reflection in the x-axis of the graph. The diagram shows the cross-section of a parabolic mirror, where x and y are measured in feet. Find the width and the height of the mirror. Use the domain of the function to find the width of the mirror and the range to find the height. The leftmost point on the graph is negative 4, 1. The rightmost point is 4, 1. So the domain is negative 4 less than or equal to x and x less than or equal to 4, which represents 8 feet. The lowest point on the graph is 0, 0, and the highest points on the graph are negative 4, 1 and 4, 1. So the range is 0 less than or equal to y and y less than or equal to 1, which represents 1 foot. So the mirror is 8 feet wide and 1 foot tall.